So, example from finance to illustrate Excel. And I know I just said a minute ago I was going to do the normal curve, but I got off in finance, so that's what I'm going to do first. We'll do the normal curve, trapezoidal graphs. Real easy to do with Excel, okay? So there's just for this example. Okay, $100 a week invested at 4%, starting at some time, and we want to see how much that's going to be worth in 40 years after your first contribution, okay? So if you do this, start when you're 20, this is when you're 60. The way I would set this up in Excel, and there are various ways it could be done, but I'd put the 100 in here somewhere, into a cell, okay? So I'm going to put $100 into B2. Okay, well, right there I did. And you just click on the B2 cell and you type it in, okay? Very simple. If you've done Excel, you know this, but not everybody's done it. So, and I'm going to put %. Well, not 4%. I'll just put actually 0.04 into B3. Okay. Right? Yeah. Okay. Now, we're going to assume that the money is being compounded, and you have to understand a little bit about compound. Let's say it's been compounded annually, just to make it simple. Okay? We can go to a continuous compounding model easily enough, and we will. But so, okay, you think $100 is going to grow 4% annually for 40 years, okay? So it grows to $100 times 1.04 raised to the 40th. Okay? Each year you multiply by 1.04 because if you're adding 4%, that means you have your amount plus 4%, means you have 1 plus 0.04 times your amount, right? Okay? Okay, so I could put in this cell leave myself room. It just takes a little bit of writing. Okay. So I'm going to have to make a little bigger picture. Since I'm going to be dealing with 1.04, just to demonstrate, it's not absolutely necessary to do this. You can put it into the calculation as 1 plus whatever's in this. Okay? But I'm going to do this. I'm going to say, in here, I'm going to say equals 1 plus B3. Okay? Now the reason I want to do that is I can set up this whole calculation with 0.04. If I want to see what happens at 3% or 5%, after I've set up the whole thing, gotten all my results, I can just change that number and everything will recalculate. Okay? And if I want to change my contribution, I said, I can't afford $100, I'm going to do $70, okay? And it'll more or less instantly, I mean in an eye blink, it'll recalculate that, okay? Make sense? You understand why I'm putting these numbers here? It's so I can play with the model and change these numbers if I want to. And see how my final result changes. Okay? So I'm doing everything in terms of the numbers in these cells. So I want to do everything by reference to these cells. Okay? That makes sense? Now I type this in, and then I hit the enter key, and it's going to then put, it's going to have it's going to show 1.04. And you'll do that with Excel. It's real easy to get used to that. Okay? Now, what I want to do, now this is not the most efficient way to do it. So I'm going to do a kind of a clumsy, beat the gnat to death with a sledgehammer solution. Then I'm going to do a simpler one, just like what we did with the orange juice, where we said, well, we can do the 0.9 thing, and now we have a simple power that tells us how much we've consumed at any point, right? We do it step by step. We can add things up, we can subtract things, whatever, or we can do it more elegantly. So I'm going to do it inelegantly, but still, it can be done. I mean, you could set it up this way. Okay, so in D3, we're going to type this. Okay, now we could type B3 because that's where our 100 is, right? Okay? Except what we're eventually going to do is we're going to do a big old shortcut, okay? So whatever I do here, I wanted to do the same thing here, but using the same numbers, most of the same numbers, okay? And in order to do that, I'm going to have to put a $sign in front of the B and a $sign in front of the 3. Because if in Excel I move from this cell to this cell by dragging this cell essentially, when it looks here for this one, it's going to look here the next time, but I don't want it to look here. I want it to stay here. The $sign says, with this quantity, it's always going to be in B, and it's always going to be in 3. The $sign does that, okay? And that B looks enough like a D. Kind of a grotesque B, but now we can see it's not a D. Okay? So I'm going to type, and I should type the equal sign. You'll get used to that, okay? So what's in this cell is going to be equal to B3 times what's in here, right? Okay? And that's what's in B5, right? So our 1.04 is going to end up here because that's 1 plus B3, right?
That's B2, and then the other one is B4.
No. This is 1, this is 2, this is 3, this is 4, this is 5. Easier to relabel it. Okay, you're right. You know, that was, when I was looking here, I was thinking 1, 2, 3. I didn't look over here. And because you want to look. Okay? That makes sense? But then I've got to raise that to the 40th power. okay? And this is where we really want to do something a little different. We don't want to have to write out this power every time. We want to do that by cell reference, okay? But does that make sense? Okay? Now, as I say, I really don't want to do that to the 40th power. So how am I going to deal with that? Because the next one, the next cell is not going to use the 40th power, right? It's going to use like the 39.98 power, okay? And I don't want to have to write this power in every time for 2,000 weeks, right? So one way to get around it is do an integral and say that's close enough, and it would be. Okay, because you can't really tell what's going to happen to the economy. You can't even tell what the money's going to be worth. So if it's off by 0.1%, you still know about how much money you're going to have, right? And about what you hope it's going to be worth. Okay, so I really don't want to do that 40th power because I'm going to have to adjust that for 2,000 times. So I want to do that by calculation. Now let's see how long this is getting. It's getting long enough.